Okay, in this problem we have students who either pass or do not pass a particular college class, and the trend is zero point 0.7, and the probability doesn't change. That's why I've said that the trend continues, and we have a sample of size 10. So n is equal to 10, and p is 0.7. Before I start answering any of the questions A, B, C, I'm going to get the probability distribution, and I'm going to use my Texas Instruments calculator for that. And so go to Stat and Edit. And in List 1, enter the numbers 0 through 10, since that's the sample size. I've already done that. If you need to, pause and do that, but I'm moving on. I'm highlighting the next column heading, the L2. Second, VARS, which will give us the distributions. And you can either arrow up or down to Binomial PDF and hit Enter. And then the number of trials is going to be 10. P is 0.7. And L1, just hit second 1. I want to get all of the probabilities into a table there, and just hit Enter and Enter. And that's put the formula down below. You can arrow here and see the whole formula. If you have an older calculator, it may have just, instead of giving you the table, it might have put Binomial PDF open parenthesis there. Just hit N, which is 10, then comma P, which is 0.7, comma where the X value or values are. In this case, they're all in list 1. And then just hit Enter. And now those are filled in. But our first question now, that takes care of just getting the table. Our first question is for 8 or more. So we'll have to get the values at 8, 9, and 10, which are 0.23347, 0.12106, and 0.0202825. And we'll add all of those up to get our answer. And for that, I get 0.38278. Then I can graph this just by hand. I might as well go ahead and do this while I'm here. Go back over here, and I'm going to have zero, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And let's see, my probabilities were, the highest was about 0.27, so 0.05, 0.1, 0.15, 0.2, and 0.25. And so now I'm just going to read all of these off of here and graph them. Well, for 0 and 1, those are both about 0. And for, let me do this in a different color here. For 2, it's not much more than 0, but I'll go ahead and put a dot there. And same for 3. 4, we're up to about 0.036, at almost 0.4, then 0.1 about, and then for 6, about 0.2. And then for 0.7, about 0.2678. And now I'm going to change colors. For my problem here, I have 2, 3, 3, 4, 7. and then 4.9, 0.12 about, and then about 0.03. Okay, and that would be my graph for this one. I'm going to go ahead and pull R over into this. Pull this off of there. And show you if you were using the program that I gave you, if you changed into 10, P to 0.3, and we want to go from 8 to 10, and then just highlight everything. That does not look exactly right. That didn't look right. That's got to be 0.7 right there. That looks better. And now we have it highlighted in blue. And there's the distribution. And there's the 0.383, which is approximately what we had in the other one, 38278. I just put the digits to 3 there. You can change that if you wanted. And that's part A of this problem. And then if you want to, you just export and copy to clipboard and copy plot, and you can put that into your document. Okay, for part B, what's the probability that 5 or fewer? Remember, 5 or fewer includes 5 or anything less, so we'll just add up I'll start with that, 5.9 e to the minus 6th. That's move your places over 6, so it's going to be 5 zeros, and then I'm going to round that to 6. And then the next one is 1.4, but it's to the minus 0.4, so 3 zeros, and then 1, 4, and then we've got 0.00145, and then 0.009, then 0.03676, and then for 5, it's 0.10292. So you'll add all of those up. And for that, I get 0.15000276, or I'd probably just put about, depending on the number of places, 0.15, about 15% of the values are 5 or less. And so let's check R out again. And this time we wanted to go from 0 as our lowest value, and 5 is the upper value that we're including in there. And now I'm just going to hit run, have my graph, have my probability, 0.15. Everything's looking good on that. Of course, you can draw the graph by hand if you would prefer. And then for part C, what's the probability that all 10? So I can just go down, and that one I'll just read right off of the test. That's or off of the table, 0.2825. Of course, you can plot the whole thing, or you can guess what I'm going to do here. Oops, I didn't write all that. I left that off of there. There's the calculation I just did. Or just really not a calculation. I just wrote it down. There it is. You can draw the graph by hand, but I'm going to use R instead. So I just go up and put 10 for both the upper and lower value. Highlight and run. You can see it's the one that's shaded in here, and 0.0282, which is what we have with the table as well. Of course, you can round that up more. And there's your whole table right there if you wanted to just copy that over and so on. Okay, there is an example of the binomial distribution and using both the calculator to obtain probabilities and also to use R to get probabilities in a graph.